Okay, so this is lecture 1. My name is Hampton. I'm going to take you through the number system. Yeah, and then I'm going to send the recorded video to the WhatsApp group early in the morning tomorrow. All right, so we begin. Yeah, so I want to start first by looking at the types of numbers. Yeah, the types of numbers, we all know these things, they may seem to be as simple as you may think, but they are very important to you. They are very important. You need to know them by heart. If you don't know these, even a fraction can be a problem to you. Yeah, even just solving a fraction, so it can be a problem to you. You just have to know this. All right, so we begin. So we'll start first with even numbers. We all know even numbers. Yeah. Or rather, let me not use the word we all know. Maybe there might be 2 or 3 here who may not know these even numbers. That's the reason why I've started from just the beginning, from the simplest things. Yeah. So even numbers are all numbers ending with the 0, 2, 4, 6, and 8. Yeah. So if you okay, let me just do this. Okay, so even numbers are numbers ending with 0, 2, 4, 6, and 8. So in short, any number that ends with any of these numbers here is called an even number. It's called an even number. So in other words, even numbers are numbers that are divisible by 2. I know somebody here can say, is 0 divisible by 2? Of course, yes. When we say any number divided, I mean 0 divided by any number, it may be 3, it may be 2, it may be 32, the answer you still get to be 0. The only thing that does not exist or that has no solution is any number, maybe 2 divided by 0. 2 divided by 0 is undefined. Yeah, it's undefined. All right. Okay. This is very important. You have to know it. You have to know them very well, because trigonometry, when it comes, you'll be required to know, because you'll be required to know whether you're dividing 0 by any number or any number divided by 0, more especially when it comes to dealing with tan. When you're dealing with tan, there are circumstances where you find maybe saying the tan inverse of maybe the root of 3 divided by 0. When you have this, it has a solution. It has a solution when you start dealing with trigonometry. I'll show you even the simplest way in which you can master the trig ratios. These are very simple. They're very simple. Okay. Yeah, the good part of me, I know how I teach these mathematics. I know how to teach it, because I always teach the simplest methods, which will enable you to remember even the time you're writing your exams. Yeah, so we're done with even numbers. So even numbers, we said these are numbers that ends with 0, 2, 4, 6, and 8. And then apart from this, you can also define even numbers to be numbers that are divisible by 2. Yeah. So proceed. We move on to odd numbers. So we're saying odd numbers are any integer, not a fraction. Note this in brackets. We're saying any integer, not a fraction, that cannot be divided exactly by 2. So in other words, odd numbers are just the opposite of even numbers. Yeah. Odd numbers are just the opposite of even numbers. When you divide a number and then you have no when you divide a number, for instance, you divide 8 by 2, 8 by 2, you get your answer to be a 4. So this entails you to say this 8 is an even number because we don't have a remainder here. But let's try dividing 3 by 2. When you divide 3 by 2, you get 1, and then there's a remainder 1 over 2, like that. So this is, so meaning this 3 here is an odd number, right? So I want you guys to pay particular attention, more especially when I start explaining the rational numbers, the rational numbers and the complex numbers. You have to know them, yeah, because there are times when you are asked to say, prove that the root of 2 is irrational. So if you don't know the definition of rational numbers and irrational numbers, you will suffer when proving this. Yeah, so you just have to know them. And then there are times maybe you are given a question to say 0.64, and then there's a bar on top here, and then you are told to say express this as a fraction. Express this as a fraction. In other words, they say rationalize this. Now, if you don't know what a rational number is, you will suffer. Yeah, so the best way is to concentrate when we are introducing these topics. You know the definition of rational numbers and irrational numbers. Yeah, either way, let's go. Let's get back to our topic here. Saying odd numbers are numbers that when you divide them by 2, you get the remainder 1, or you get a remainder there. In short, they are numbers that cannot be divided exactly by 2. I know somebody here is asking themselves to say, what of 1? Is 1 an odd number? Let us try to divide 1 by 2 here. When you divide 1 by 2, the answer you get is 0. 2 into 1 is 0. Remainder 1 over 2. So the whole number here is 0. The whole number here is 0, and then the remainder is 1 over 2, like that. So please, if you have any question, you can interrupt. I allow that, because in most cases, when I say you ask question at the end of the lesson, it becomes difficult for some people. Some of them tend to forget their questions. So what I do is, if you have any question right now, you can just interrupt. You can raise your hand, I'll point at you, and then you ask, and I'll respond to you just right here. I want, when we are done with everything, at least everyone has gotten something. So let's proceed. Okay? So make sure that you pay attention, more especially on rational numbers and irrational numbers. A lot of people miss those points, and they find some of the simplest things in mathematics to be held to them. Anyway, let's continue. So complex numbers. What are complex numbers? I'm sure most of us know what complex numbers are, because we did this last semester. Complex numbers are numbers that are in the form a plus I b. This is the simplest definition of a complex number. It's given by z being equal to a plus ib. And then we know to say this a here is a whole number, and it's called the real part of a complex number. And then this b here is the complex part. Yeah. I think complex numbers, there is nothing much to explain here. Let's proceed. We move on to prime numbers. What are prime numbers? So prime numbers, these are numbers with only 2 factors. What are these numbers with only 2 factors? Or rather, what do we mean when we say these are numbers with only 2 factors? Numbers with only 2 factors, we simply mean there are only 2 numbers that can go into that particular number. So let's take, for instance, you have 1. Okay, not 1. Let's start with 2. 2. 2 here, is 2 a prime number? Yes. How do I know? Because I know that there are only 2 numbers that can go into 2 without leaving a remainder. You have to understand what a factor is. We're saying these are numbers with only 2 factors. Now you have to understand what a factor is. A factor is a number that can go into another number without leaving a remainder. So when we say these are numbers with only two factors, we simply mean these are numbers which only have two numbers that can go into them without leaving a remainder. Yeah. So examples of prime numbers are here. We have 2, we have 3, we have 5, 7, and 11. But there are a lot of prime numbers even as you go counting, going up like that. All right, let's proceed. Okay. Okay. All right. Then we have natural numbers, also called positive integers. So natural numbers are simply counting numbers. Yeah, they are simply counting numbers. So these counting numbers are, when we talk of counting numbers, when you are counting, you don't start with 0. So meaning these are counting numbers, or rather positive integers, excluding 0. You don't add a 0 when you're talking about natural numbers, and they are denoted by the letter n. This is the notation of natural numbers. When you see this side, okay, let me just, okay, natural numbers, all right. So they are denoted by the letter n. Natural numbers are also called positive integers. So in short, when we talk of natural numbers, these are counting numbers starting from 1, excluding 0, going up. You only consider positive integers or positive numbers, not negative. All right, this one is straightforward. Let's proceed. So we talk of now whole numbers. Whole numbers are denoted by the letter W. Okay, and then whole numbers are a set of natural numbers plus 0. So in short, when you add a 0 to all natural numbers, you have a set of whole numbers. So whole numbers are a set of counting numbers. Since we said natural numbers are counting numbers, so all numbers are a set of counting numbers including 0. Yeah, this plus here simply means including 0. Yeah. So when you start with 0 and counting, going up, then you are talking about whole numbers. When you start with 1, you exclude the 0, then you are talking about natural numbers. Okay, let's proceed. So integers. So integers is the set of whole numbers plus all negatives or opposites of the natural numbers. So when you talk about integers, integers are a set of whole numbers including the negative numbers. So when you exclude the negative numbers, it means that you're talking about whole numbers. When you include the negative numbers in natural numbers, it means that you're talking about integers. So integers are in simple terms, you can say are numbers on the number line. Yeah, a number line includes numbers on the negative sides, 0, and then on the on the positive side. All right. I'll proceed. We move on to now rational numbers. So rational numbers are denoted by the letter Q, as you can see here. Integers is Z. Wherever you see a Z in sets or anywhere, just know that they are talking about integers. Then where you see Q, Q simply means rational numbers. So rational numbers, we're talking about a set of all fractions where the top and the bottom numbers are integers. The top and bottom numbers are integers. The denominator cannot be 0, but the numerator can be. So in short, when we talk about rational numbers, we're just talking about fractions in their simplest form. Yeah. Both the top, the numerator and the denominator are integers. So these are rational numbers. Okay. Hope we are listening and hope, because this is simple. And if you want, you can be taking notes, but I'm going to send this slide to you. You're going to have it. I'll send it in the group together with the recorded video. Yeah. Then and then tomorrow we'll come and proceed. We'll start rationalizing. We'll start proving what maybe given the root of maybe 2. Sorry, not tomorrow. I don't know if we're going to meet tomorrow. It will be up to you guys. We're going to decide the days we're going to be meeting from the group. Yeah. So immediately after this meeting, we're going to have a meeting from the group. We're going to decide when we can be meeting. Okay, so in the next meeting, we're going to be rationalizing. We're going to have questions such as, maybe they're asking you to show that the root of 2 is an irrational number. How do you show that? You first need to know the definition of an irrational number. What is an irrational number? In other words, or in simple terms, you can say an irrational number is just the opposite of rational numbers. Let me see if there's something here. Yeah, actually, this was my last page. Yeah, so in other terms, irrational numbers or rather, they're just the opposite of rational numbers. And then the definition of irrational numbers, the definition of rational numbers, the simplest definition and the shortest definition of rational numbers, which even works when you're proving that the root of 2 is an irrational number, is this one. So the shortest form or the simplest form or the simplest definition of irrational numbers, is this one here. We know to say, sorry, the simplest definition of rational numbers is that we know to say these are fractions where so in short, we know to say this is a fraction, meaning it can be expressed in the form A over B, and then where A and B are members of what? Integers. Remember what I said, wherever you see this Z, we're simply talking about integers. So it can be expressed in the form A over B, where A and B are members of integers, and always B is not equal to 0. Yeah, B is always not equal to 0. So this is the simplest definition of rational numbers. If you just know these ones here, the questions that we're going to be answering in the next lesson that we're going to have will be simple to you. So this is the simplest definition of a rational number. All right, I think we are done. Oh, we are remaining with real numbers, sorry. Let me just explain on real numbers. Let me just say something on real numbers, then we close the meeting. All right, so real numbers. Okay, somebody is raising the hand here. Let me just hear what he wants to say. Okay, let me just do this. Okay, what's your question? Okay.
I would like to know the definition for irrational, since you have taught us about rational, now irrational.
Oh, you want to know the definition of irrational? All right. Okay.
Sure.
All right. Okay, I'll explain it after explaining real numbers.
Okay.
All right. Yeah, so we proceed. So when we talk of real numbers is actually the set of all numbers In short, real numbers, when you talk of real numbers, a set of real numbers is just equal to, let me just write it in set beta notation. A set of real numbers is just equal to, or what? It's just a set of rational numbers and irrational numbers. How can I write it? Okay, let me just do this. Yeah, so when we mix, so this is the symbol for real numbers. So when we mix rational numbers, which is Q, and then plus irrational numbers, I'll just denote it as irrational. I'll just denote it with the short form of it. So when we mixed irrational and rational, the outcome there is a set of real numbers. So real numbers is just a set of all rational numbers and all irrational numbers. When you put them together, you get a set of real numbers. Yeah. When you put rational numbers and irrational numbers together, you get a set of real numbers. So this is what everything here is talking about. So this simply means that it includes all numbers. Yeah. When we start talking about sets, we'll start dealing with these kinds of brackets. Let me show you. Yeah, these ones. So we're going to know what these brackets mean, and I'll make sure that I explain. Yeah, and I'll make sure that everyone understands. Yeah, so when you talk of real numbers, it's just simply the set of all rational numbers and all irrational numbers. And then let me now explain the irrational numbers. What are irrational numbers? Remember what I said? I said rational numbers are numbers that can be expressed in the form A over B, where A and B are members of integers like that. And then, yeah, so rational numbers are numbers that can be expressed in the form A over B, where A and B are members of integers. And then we know to say B will never be equal to, yeah, B will never be equal to 0. So when we talk of rational numbers, this is what we're talking about. Now, somebody asked to say, I explained what rational numbers are, and then I didn't explain what irrational numbers are. So now, irrational numbers, in other words, is the opposite of rational numbers. How is it the opposite? So when we talk about irrational numbers, these are numbers that cannot be expressed in the form A over B. So when you talk of an irrational number, you can't express it in this form. It's impossible for you to express it in this form. If you want to prove this, get any calculator, try to punch this, try to punch the root of 2 or the root of 3, even just the root of 6. Try to punch these on your calculators. Yeah, and then the numbers that you get, I want you to try. There is an option of, I know there are some people here who know how to use the calculator very well. You can easily convert any decimal number to a fraction using a calculator if you just know how to use it very well. Now try to punch this on your calculator, and then after punching this on your calculator, try to see if there are ways in which you can express the outcome, or rather the answer that you're going to have as a fraction. So if you discover that there is no way that you can express these numbers in the form A over B, just know to say they are irrational numbers. In other words, irrational numbers cannot be expressed in the form A over B. So this is the definition of irrational numbers. Rational numbers, you can express them in the form A over B. Yes. So you guys, I hope I've answered your question. Yeah, I hope I've answered your question. So please make sure that you don't miss the next lecture. We're going to be discussing important things there. Yeah, the key things for this semester. So please don't miss the next one that we're going to have. Don't miss. Yeah. So this is the end of the lecture. If you have no questions, I'll end the meeting. But let me give you maybe 1 minute to think. If you have any questions from what we have learned, yeah, you can ask in these remaining seconds. Okay, you can raise your hand. There's an option of raising your hand on your phone there, on your tablet, on your computer. So you can raise your hand. I'll point at you. Then I'll hear your question and answer. But please just make sure to say the next lecture you don't miss, because when you miss, you're going to miss a lot. This one, I just planned it for us to meet for 40 minutes. Okay, let me just hear from what these people are saying. Okay, let me start with Solomon. Okay, Solomon, you can speak. Hello, Solomon. Oh. Okay, Godwin, you can speak in this remaining 1 minute. It seems people do not want to speak. Okay, you are going to inbox me, rather you send your question to the WhatsApp group. I'm going to answer, I'm going to respond from there so that we discuss even the days we're going to be meeting in a week. And what you should put in mind is that we're going to be meeting for 1 hour, 30 minutes on those particular days we're going to choose. All right, thank you very much for watching. See you in the next meeting. Please don't miss, I repeat.